Hey guys, my Rishabh. Today we are going to talk about the graphical integration in motion analysis. So, graphical integration in motion analysis. So we can integrate on a graph to find the object's velocity. And so we can write as let's take acceleration as a equal to dv upon dt, and also we can rewrite it as a dt equal to dv. So the fundamental theorem of calculus tells us that from fundamental theorem of calculus, we can write v1 minus v0 equal to t0 to t1 a dt. The right side of the equation is definite integral, and here from this equation we can understand that v0 thanks to t0 and also v1 thanks to t1. So the definite integral can be evaluated from AT graph. Let's draw a AT graph. This is just an example, and A and T, this is T0 and T1. So the area between the plotted curve and the horizontal axis, which is also called horizontal time axis, and this graph represents the graph of acceleration versus time. Graph of acceleration versus time. That is, we can write t0 to t1 a dt equal to area between acceleration curve and time axis. Area between acceleration curve and time axis from t0 to t1. So if we want to understand it, let's take a unit of acceleration as a unit of acceleration, not that unit, the amount of unit acceleration is, let's say, 1 meter per second square, and that's time is 1 second, and then the corresponding unit of area on the graph is, we can say, 1 meter per second square multiply 1 sec equal to 1 meter per second, which is the velocity. So the acceleration curve above t axis is a positive acceleration. This is a positive acceleration, and below it will be negative acceleration. So moving on, similarly, because velocity is defined in terms of position x, moving on, velocity v is defined in, is or can be defined in terms of position, let's say x. So we can write it as v equal to dx upon dt, or v dt equal to dx. So then the integral form of this equation will be x1 minus x0 equal to t0 to t1 v dt, where x0 tends to t0 and x1 tends to t1. So we can write it as, first of all, we have to draw a graph of Vt. Let's take the graph as this. And this point is t0 and t1, and this is the area. So this is Vt graph. So from the graph we can say that t0 to t1 v dt equal to area between velocity curve and time axis from t0 to t1. So that's all for graphical integration in motion analysis. This is a short video, and in the next video there will be some questions on kinematics, because we have to practice to understand the basic concept of the kinematics. So this is the last video of all the concepts. So thank you.